Jam. So it's around 11 p.m. right now, and I'm at my house. So welcome to my house. I will show you around, but I'm scared some of you might stalk me. So we're just gonna keep it here. I'm actually at my desk. So what we're gonna do today is we're gonna learn about 2.6 graphing absolute value. And you'll probably ask me, well, what does graphing absolute value have to do with systems? Well, nothing really. Actually, absolute value is not even a standard, to tell you the truth. Then why do we do it? Because I think absolute value has a lot of things that leads itself to graphing parabolas, which is our next chapter, quadratics, our next unit. So I want to talk about graphing absolute value real fast. So pretty much the idea is I want to talk about parent functions, and every graph has a parent function. The parent function is usually the original function, the original graph. And then all the other stuff that add on does something to the graph. What though? So we're going to talk about, well, if I add on this, what does that do to the graph? If I add on this, what does that do? And so on and so on and so on. So let's take a look. What does a parent absolute value function is? And that's the very, very basic of the function. Looks like this. Y equals absolute value of x. Just like that. Parent function. Basic. No, nothing else. So every time you see a graph and you're like, whoa, what does that look like? I'm not too sure. Always just try to plot points and make dots on the graph and figure that out. And that's how computers graph it. They just put a bunch of points, a million points in there, and actually they see the dots and they connect the dots and they have a graph. That's basically what it is. So I'm just going to put a bunch of points in there randomly. And when I mean randomly, I already picked them out ahead of time. -2, -1, 0, 1, 2. Alright, and I'm going to plug these in. Right now, can you pause the video and plug them in yourself and then see if you match me? I'm going to plug it in right now. Y equals absolute value of 2. Absolute value of 2. Take out my calculator real fast. Alright. Absolute value of 2 is 2. Perfect. Therefore, when I plug in a -2, I get +2. When I plug in a -1, I get 1, 0, 1, 2, and so on and so on and so on. Plug them in, see if you got those same answers. Now I'm going to graph that. I'm going to graph the parent function. And I'll graph it in black so you can see. So, what does it look like? -2, 2. And pause it and see if you could graph it yourself. Then check your answers of what I'm doing right now. -1, 1, 0, 0, 1, 1, and 2, 2. And therefore, look at that. What does that look like to you? To me, it looks like a V. So I'm going to graph it out. It makes a V. And therefore, the parent function is a V. Absolute value graphs a V all the time, every time. Very interesting. So, why, right? Why is it a V? If you notice, the exponent is 1, so really it's supposed to be a line. It's actually a line. And what happens, you go down the line, and then you can't get to the negative part, because every time you put a negative number, it becomes positive, it kind of reflects back up here. And there you go. There's a basic parent function of absolute value. Alright, now let's add some numbers, see what numbers do. No, so for example, what if I did this instead now? What if I took, y equals the absolute value of x plus 2? What if I added 2 on the outside? What would that do to the graph? What do you think? Before you even start it, what do you think that would do? Will it move it? Will it make it smaller, thinner? Will it move it left, right, up and down? What do you think real fast? You got it? Alright, good. So I'm going to actually, I don't know yet because I don't know. So I'm going to actually try to plug in points. Again, -2, -1, 0, 1, 2. And try to see what that looks like and graph it. So pause again and plug those in and see what you guys get. I'm plugging -2. Y equals absolute value of -2 plus 2. Absolute value of -2 is +2 plus 2. Y equals 4. When I plug in this, I get 4. Do the rest. Plug in -1, I get 3, 2, 1, 0. Now take a look. Let me pick a color here. I'm going to graph this for you in blue. So this is going to be in blue. -2, 4. Same graph, so I can compare it to the parent function. -2, 4. 1, 2, 3, 4. Make my dots. -1, 3. 0, 2, 1, 3, and 4. Take a look at that. That makes a V also, right? This blue is a little dark. Let me pick a lighter blue. Baby blue. Oopsie. Take a look at this graph. Take a look, take a look. Look at that. Is this as interesting to you guys? Sure is. Alright, take a look at that. Compare that to the parent function. What did that 2 on the outside do? It looks like it shifted up 2. So if you see any number on the outside, it's known as a vertical shift. So if it's a plus 5, it's going to move the parent function up 5. If it's a minus 2, it's going to move the parent function down 2. Very good. So let's do another one. One more. So what if, now I want to graph this, y equals absolute value of x plus 1. Now what if I put a 1 inside the absolute value? What do you think that's going to do to it? Is it going to move it up, down, left, and right, make the graph skinny, make the graph fat? What do you think that's going to happen? So think about it. You got it? Good. Now I want to make a t-table again, and I'm going to plug in numbers and check it. But I'm going to pick numbers differently now because I know what I want. So I'm pick different numbers now. I'm pick -3, -2, -1, 0, 1. Plug it in. Pause it. Plug it by yourself. I will start plugging them in right now. Y equals -3 plus 1. Y equals -2 plus, or -2. Absolute value of -2 is +2. Very good. This is a +2. So on and so on. Get the rest of your answers. 1, 0, 1, 2. I'm going to graph this in red for you. So this one's going to be in red. -3, 2. -1, 2, 3, 2. -2, 1, 0, 1, 2. I want to take a look at that V right now. I'm going to draw it out. And look at that. Compare that to the parent one. Compare that to the black one. What do you notice about that one? How did it move? It looks like it moved to the left 1. Interesting. Ask yourself, why to the left? Look at this. Isn't that a +1? Wouldn't it move to the right 1? Interesting, right? So ask yourself that. Try to figure out an answer. And let's do actually a real graph, what you'll be doing for homework and what you'll be doing on the test. So you notice, big review. If you see a number on the outside, it's known as a vertical shift. It moves it up and down. When you see a number on the inside, it's called a horizontal shift. It moves it left and right, but it looks like it does the opposite. So remember that. Take a note of that. Let's actually look at the equation of absolute value real fast. The equation of absolute value looks like this. Equation of absolute value. It's going to be y equals m x minus h plus k. Make it a little darker. Y equals m x minus h plus k. So take a look. Every equation has x and y dealing in 2 dimensions here. Then you have other variables. You have m, you got h, and you got k. What do those variables mean? So let's write that down. M. You heard of m before, correct? M is the slope. Wait, this has a slope? Well, yes. It's a line. So we're going to talk about that. It's actually called a pseudo slope. It's very interesting. What's h then? H is known as the horizontal shift. Or I like to call it the crazy horse. Crazy horse are known as horizontal shift. So what's k then? K, I like to call it the kite. And I'll explain right in a second. And that's known as the vertical shift. And this is how I memorized this. Actually, this came up with a teacher that used to work here. So think about horse. How does a horse move? Horse usually moves left and right. So where is it located? Inside. So think about this. Horse is crazy horse. So it's crazy because it kind of does the opposite. Remember we talked about opposite? And remember they have a negative here just to remind you that does the opposite. So crazy horse does the opposite. And if something's crazy, like a person is crazy, what do you want to do? You want to lock it up. So you notice the horse is always going to be inside something locked up where it's not going to go outside and like kill people and stuff. Yeah, it's crazy. What's a kite? How does a kite go? Kite is actually, you fly a kite. So kite's up and down. Is a kite crazy? No, because it's a kite, right? It's a kite. So kite goes up and down. Kite's outside free flying. So let me graph one for you to see. Take a look. I'm graph this. Example. Y equals 1/2 x plus 1 minus 3. So before you graph this, you need to find 3 components, right? Your 3 components are m, h, and k. Let's find m, h, and k. So write this down together. You need to find m, you need to find h, you need to find k. What's m here? Remember, slope on the outside is right here, 1/2. What's my h? My h is on the inside here. It's 1, but remember it's crazy horse, so you're going to put a -1. And then what's my k? My k is on the outside flying free. That's going to be a -3. It's not crazy. Whatever number you see there is the number you use. I'm going to graph this now. I graph as something called the vertex. And what's the vertex? The vertex is right here. The vertex is here, here, and here. It's kind of like the tip of the graph. So I'm going to start on my vertex. My vertex is at h comma k. What's my h? My vertex is at -1 comma -3. So when I'm graphing this, I start at -1 comma -3. Make sure you make your graph x, y. So -1, -3, -1, -3. I make my vertex right there. Then, do I need to plot points? Not really. I can actually use the slope to help me. And only lines have slopes. Remember, in parabolas, we're not dealing with slope anymore. Anything with curve doesn't have a slope. So take a look over here. We graph it. It looks like slope of 1/2. That means 1 up, 2 to the right. 1 up, 2 to the right. But that only gives me one side of the V. To get the other side, you have to go 1 up, 2 to the left. So now we're going rise, and then we're running both ways. Rise, then we're running both ways. 1 up, 2 to the left. 1 up, 2 to the left, and take a look. I just graphed my V without having to make a T table. Oop. Host process Windows service has stopped working. Oh, that sounds bad. Alright. So there you go. Take a look. And that's my graph. Very good. So a couple things you might notice. We're going to practice this in class, but ask yourself, what happens if this is negative? What happens if this is negative? What happens if there's no horse there? What happens if there's no kite there? What are you going to do? Alright, that's it. Guys, have a great day.